76 miles north of Elko, Nevada, is the Big Springs Mining District. This was actively operated from 1986 until 1993. The mine was closed due to economic and environmental issues. Following the closure, the pits and waste rock dumps were reclaimed to meet the then current environmental regulations. Innova Metals acquired the mining claims over the project in 2013 and have subsequently submitted permit applications to recommence mining. The main purpose of this mapping project is to provide accurate topographic data for final mine design. In a preliminary flyover, we can see that the property is relatively small, but has a great deal of topographical changes and mixed strata. The walls of the pits are really interesting. You can see the ore bodies driving straight through from one side of the mountain to the other. However, as the mine has been closed for many years, climbing around on the cliff faces would be extremely dangerous. There's lots of data available through historic drilling, but up close view would certainly help the geologist evaluate the property, and slope stability analysis is needed by the mining engineers. We were asked to provide a detailed elevational map for the entire project site. Let's focus on the main pit first. Our objective was to get a high-resolution mosaic of the pit wall so that our customer could take a close-up view of the details on the wall. This huge digital picture not only gives us the scope of the wall itself, but allows for zooming in on different areas to see the different layers or the individual rocks themselves. The mosaic uses pictures taken from all different angles and makes a 2D picture wrapped around a particular point in space. Many of the pictures were taken straight down from an altitude of about 100 feet above ground. Using only those pictures creates a high-definition map that's 2D and from the vantage of straight down. This top-down map allows us to make a 2D dimensional map, which is another mosaic but results in a colorized digital elevation map. Combining all these renderings and adding GPS locations provided in each picture, we create a full three-dimensional object view of the pit. The entire area needs a digital elevation map. In order to tie the elevation map to a known grid, we need to nail down surveyed points spread out evenly across the entire property. Once we have the targets out, we can start collecting data. Next, we flew the site collecting downward-facing pictures from a consistent 400 feet, collecting over 6,000 pictures over the 1.5 square mile area. We trimmed the pictures down to 4,500 individual pictures, tied them to ground control points, and processed the data over several days. Each picture used is a blue frame here, and each of the blue flags is a surveyed GPS point. After processing, we have what we call a dense point cloud. This consists of 3.8 million tie points and over 290 million ground points. The point cloud has a resolution of 4 centimeters per pixel and an overall accuracy, when we're said and done, of 6 centimeters. Once we do that, we can create a digital elevation map with contour lines at 1 meter. We basically created a super accurate topo map for the entire property. All total, this project took a couple days just to drive there and back, and about 2 days of field work, flying, and about a week of software work. We hope this video has been informative to our customers, our students, and the UAV community. Thanks for watching.